Object-oriented programming, or OOP, is a programming paradigm that organizes software design around data, or objects, rather than functions and logic. This approach helps programmers structure complex code in a way that is more manageable and easier to understand. OOP is widely used in modern software development, forming the backbone of many popular programming languages like Java, Python, and C++. In this video, we'll explore the core concepts of OOP, its advantages, and how it shapes the way we write code today. Let's start by understanding why OOP matters in the world of programming. Roots of object-oriented programming date back to the 1960s, when researchers sought better ways to manage growing software complexity. The concept was first introduced with the Simula language, which pioneered the use of objects and classes. Over the decades, OOP evolved and became a fundamental part of languages like Smalltalk, C++, and Java. Today, OOP principles are embedded in many modern programming languages, making it a crucial skill for developers. Understanding this history helps us appreciate how OOP has shaped the software industry. The heart of object-oriented programming are four core principles: encapsulation, abstraction, inheritance, and polymorphism. These principles guide how objects interact, how data is protected, and how code can be reused and extended. By mastering these concepts, programmers can write code that is modular, flexible, and easier to maintain. In the following scenes, we'll break down each principle and see how they work together to make OOP so powerful. Encapsulation is about bundling data, and the methods that operate on that data into a single unit, known as an object. This principle helps protect the internal state of an object from outside interference and misuse. By controlling access to the data through methods, encapsulation ensures that objects manage their own state responsibly. This leads to more secure and reliable code, as changes to one part of the program are less likely to affect others unexpectedly. Abstraction allows programmers to focus on what an object does, rather than how it does it. By exposing only essential features and hiding the complex implementation details, abstraction simplifies code and makes it easier to use. This principle is key to managing complexity in large software systems, as it lets developers work with high-level concepts without getting bogged down in the details. Inheritance is a mechanism that allows one class to inherit properties and behaviors from another class. This promotes code reuse and makes it easier to create new classes based on existing ones. For example, car class might inherit from a more general vehicle class, automatically gaining its attributes and methods. Inheritance helps organize code in a hierarchical way, making it more logical and maintainable. Polymorphism enables objects to be treated as instances of their parent class rather than their actual class. This means a single function can work with different types of objects, making code more flexible and extensible. For instance, a function that processes shape objects can handle circles, squares, or triangles, each with their own implementation. Polymorphism is essential for building scalable and adaptable software. OOP, a class, is like a blueprint defining the structure and behavior of objects. An object is an instance of a class containing real values instead of placeholders. For example, a dog class might define properties like breed and age, while an object would represent a specific dog with actual values. Understanding the relationship between classes and objects is fundamental to mastering OOP. Define a class. In most OOP languages, you specify its name, attributes, and methods. Attributes represent the data, while methods define the actions the object can perform. For example, a person class might have attributes like name and age, and methods like speak or walk. Defining clear and meaningful classes is the first step to building robust OOP systems. Once a class is defined, you can create objects from it. Each object is a unique instance with its own data. For example, if you have a car class, you can create multiple car objects, each with different colors or models. Creating objects is how you bring your OOP designs to life, allowing your program to interact with real-world concepts. Methods are functions defined inside a class that describe the behaviors of the objects. They allow objects to perform actions or modify their state. For example, a bank account class might have methods like deposit or withdraw. Methods are essential for encapsulating logic and ensuring that objects interact with their data in controlled ways. Attributes, also known as properties or fields, store the data for each object. They define the state of an object at any given time. For instance, a book class might have attributes like title, author, and pages. Properly managing attributes is key to maintaining the integrity and usefulness of your objects. Constructor is a special method used to initialize new objects. It sets up the initial state by assigning values to attributes. In many languages, constructors have the same name as the class. For example, when you create a new user object, the constructor ensures it starts with the right information. Constructors make object creation consistent and reliable. Access modifiers control the visibility of class members, such as attributes and methods. Common modifiers include public, private, and protected. These keywords determine whether other parts of the program can access or modify certain data. Using access modifiers wisely helps enforce encapsulation and keeps your code secure and organized. Let's look at a practical example of inheritance. Imagine you have a vehicle class with attributes like speed and methods like move. You can create a bicycle class that inherits from vehicle, automatically gaining its properties and behaviors. This allows you to add new features to bicycle without rewriting existing code, demonstrating the power of inheritance in OOP. Polymorphism lets you write code that works with objects of different classes as long as they share a common parent. For example, a function that draws shapes can accept circles, squares, or triangles, each with their own draw method. This makes your code more flexible and easier to extend, as new shapes can be added without changing existing functions. Abstract class is a class that cannot be instantiated directly. Instead, it serves as a base for other classes, defining common attributes and methods. Abstract classes often include abstract methods which must be implemented by subclasses. This approach enforces a consistent interface while allowing flexibility in implementation. Interfaces define a contract for what a class can do without specifying how it does it. Classes that implement an interface must provide concrete implementations for its methods. Interfaces are a powerful way to achieve abstraction and polymorphism, allowing different classes to be used interchangeably if they share the same interface. While inheritance is a core feature of OOP, composition is another important concept. Composition involves building complex objects by combining simpler ones, rather than inheriting from a parent class. This approach can lead to more flexible and maintainable code, as changes to one component don't affect others. Knowing when to use composition versus inheritance is a key skill for OOP developers. Let's apply OOP concepts to a real-world scenario. Imagine designing a library system. You might have classes like book, member, and librarian, each with their own attributes and methods. By using inheritance, abstraction, and encapsulation, you can create a system that is easy to expand and maintain as the library grows. Java is one of the most popular languages for OOP. Its syntax and structure are designed around OOP principles, making it a great language for learning and applying these concepts. Java enforces encapsulation, supports inheritance and polymorphism, and provides powerful tools for building object-oriented applications. Python is another language that embraces OOP, offering a simple and readable syntax. In Python, everything is an object, making it easy to apply OOP principles. Python's flexibility allows you to mix OOP with other programming styles, giving you the best of both worlds for different types of projects. C++ is a powerful language that introduced OOP features to the world of systems programming. It supports classes, inheritance, polymorphism, and more, allowing developers to write efficient and organized code. C++ is widely used in applications where performance and control are critical, such as game development and embedded systems. OOP offers many benefits, including improved code organization, easier maintenance, and greater reusability. By modeling real-world entities as objects, OOP makes software more intuitive and easier to understand. Its principles help teams collaborate effectively and adapt to changing requirements with minimal effort. While OOP has many strengths, it's not without drawbacks. OOP can introduce complexity, especially in large systems with deep inheritance hierarchies. It may also lead to performance overhead due to abstraction layers. Understanding these limitations helps you make informed decisions about when and how to use OOP effectively. Procedural programming focuses on functions and procedures, while OOP centers on objects and their interactions. OOP is better suited for complex, evolving systems, while procedural programming can be simpler for small, straightforward tasks. Knowing the differences helps you choose the right approach for your project. Design patterns are proven solutions to common software design problems. Many patterns, such as singleton, observer, and factory, are based on OOP principles. Learning design patterns helps you write code that is more robust, reusable, and easier to maintain, making you a more effective developer. OOP remains a cornerstone of modern software development. From web applications to mobile apps and enterprise systems, OOP principles guide the design of scalable and maintainable solutions. As technology evolves, OOP continues to adapt, ensuring its relevance in the ever-changing world of programming. Even experienced developers can make mistakes with OOP. Common pitfalls include overusing inheritance, creating overly complex class hierarchies, and neglecting encapsulation. Being aware of these mistakes helps you write cleaner, more effective code and avoid unnecessary complications in your projects. We've covered the fundamentals of object-oriented programming, including its core principles, practical examples, and real-world applications. OOP is a powerful tool for building organized, maintainable, and scalable software. As you continue your programming journey, practice applying OOP concepts to your own projects and explore advanced topics like design patterns and frameworks to deepen your understanding.